So the good thing is I only have 16 minutes of time during lunch break to do this, so I'll make it quick. This is the transformations of y equals absolute value of x. And we're going to graph y equals absolute value of x and state the domain and range. That's where we'll start. We'll start by making a table. And I'm going to use the 3 points I always use, -1, 0, and 1. Now, the absolute value of -1 would be 1 because absolute value is the distance from 0. The absolute value of 0 is 0, and the absolute value of 1 is 1. So there's my 3 key points. I contain -1, 1, 0, 0, and 1, 1. And it's called absolute value. Starts with a V, looks like a V. The domain and range, this thing will run forever left. So -infinity to +infinity because it runs forever right. Now its range, and again, range is your y values. You know, we have to know the difference between domain and range. The lowest y value is 0, and it rises on either side of the V to infinity. Or, if you like set builder notation, all values of y such that y is greater than or equal to 0. And over here, something I forgot, or all values of x such that x is an element of the real. It's XER. My calibration's a little off. Sorry. All right, types of transformations. We can have a translation. This would be a shift up or down, or it could be a shift or a horizontally. That would be vertical, right? It could be a horizontal shift as well, which would be left or right. Those are your translations. You can be the vertical shift up or down, or you can be the horizontal shift left or right. A reflection is when you flip over an axis. Now, Algebra 2 primarily deals with vertical reflections. I'm not entirely sure that horizontal reflections are in our standards. Like, I see some need for them to be talked about, but I don't think they're actually something that's really talked too much about. A stretch, you can have either a horizontal or vertical compression, and we usually deal with vertical compressions or vertical stretches. It can be a vertical stretch or a compression. And again, I think the horizontal aspect is past this. Anyways, I don't know why I mentioned those separately. You can be a stretch or compression. Now, a stretch is when you grab a graph and you pull on it and make it taller. A compression is when you push it down and make it wider. Anywho, those are your types of transformations. Here's the vertex form for absolute value. Y equals a times the absolute value of x minus h plus k, where a is the, and again, we think about this as slope. It's kind of what it is, because absolute value are still dealing with rays, which are linear concepts. HK is the vertex. And if A is a number stuck between 0 and 1, sorry, if the absolute value of A is a number stuck between 0 and 1, then the graph is compressed. If the absolute value of A is greater than 1, then the graph is stretched. Now, I also need a little note here that says if A is negative, not the absolute value of A, but if A is negative, the graph is vertically reflected. Maybe I'll remember to put that in the notes by the time I make copies. Who knows? But there's the vertex form for absolute value. And if you need to pause, go ahead and pause, but I'm trying to get this done in my lunch break. Identify the transformations in the equation f of x is 3 times the absolute value of x minus 3 plus 2. So we're just going to do a simple lineup process. I'm going to line that up with a times x, the absolute value of x minus h plus k. And I see that a is 3. And the absolute value of 3 is bigger than 1. So I have a vertical stretch with a factor of 3. Now, I'm going to pull out h and k. Notice that there's a negative sign here. Like literally h is 3. So 3, 2 is the vertex. And it's not a graphing problem. but the vertex is right 3 up 2. There's where your V is going to be, okay? Contrast that with mom, who would be right there. So we have horizontally shifted right 3. You might also see somebody say translate right 3. And we have vertically shifted up 3. And that's the transformations that are present in that equation. Again, pause if you need to pause. G of x is a transformation of f of x equals the absolute value of x. Now, the instructions don't say it, but we're going to graph absolute value of x. I'm just going to do it dashed lines, okay? Identify the transformation in g of x is negative 2 times x plus 1 minus 3, then graph both f of x and g of x. Okay, so it did say graph. Transformations here are, notice that negative sign, there is a vertical reflection, it will open down. There is a vertical stretch because the absolute value of negative 2 is 2, which is bigger than 1. It is taller, it is narrower. And our vertex here is going to be at negative 1, negative 3. Do opposite of whatever this says inside. This is not a shift right. We have shifted left 1. We would call that horizontal translation, left 1, and then down 3. The slope would be negative 2. That's going to make that V open down, okay? So anyways, let's go ahead and kick some stuff in here. We figured out that it was a left 1 and down 3, and then our slope is negative 2. Now V's got two sides. There she is. So there's mom. This is the f of x being the absolute value of x, and this is the child function. G of x is negative 2 absolute values of x plus 1 minus 3. Domain is always inherited from the parent. So mom's domain was negative infinity to positive infinity, so is the child's. Range is going to be a little tougher because range you have to think about. We talk about the smaller number first, and this thing is falling towards negative infinity, and then it is rising up to negative 3. And that negative 3 is something that I can put my pencil on, so I use a bracket. Or, if I like set builder notation, which most people don't, y is less than or equal to negative 3. Inequalities are something you just got to study and try to figure out on your own. That's what they are. Alright, g of x is a transformation of f of x equals absolute value of x, so let's go ahead and graph the mom function. Identify the transformations in g of x equals 1/2 of the absolute value of x minus 4 minus 3. I'm going to go ahead and graph first. Right 4 down 3. Slope is a half. Rise half a unit, run 1. Looks like that. The a value is actually what we call initial slope in a lot of things. That's why I didn't rise 1 or run 2, because I don't want to really teach that, because that'll make you mess up on some other stuff. Mine's a little too steep, but there's the gist of it. Alright, the transformations that were happening were obviously we shifted right 4. We shifted down 3. And this thing was not stretched since a is a half, right? And we have a note that says 0 less than or equal to less than the absolute value of a less than 1, we have a compression. Because a half is less than 1, but more than 0. Slope was a half, the vertex was at 4, 3. And again, domain is always inherited from mom. It's negative infinity to infinity. The range has a low value of negative 3, and it rises to infinity on either side of the v. As an inequality, all values of y such that y is greater than or equal to negative 3. 2 to go. I'm about out of time, too. All right, g of x is a transformation of the absolute value function again. So there's the absolute value function. Identify the transformation in negative absolute value of 8x plus 16 minus 3. Now we're going to do something here. We're going to do FAFO, which means factor and find out. We're going to pull the negative 8 out. And if we pull a negative 8 from negative 8x, we have an x left. If we pull a negative 8 from 16, we have a minus 2. The reason I did that is because you have to be in the form of a times the absolute value of x minus h plus k. I have to have a singular x to use that form, so I pulled that out. The negative sign tells me there is a vertical reflection opposite of what's inside, right 2, down 3. Look at where my pencil was. Right 2, down 3. The vertex is at positive 2, negative 3. And I'll graph from here on out. So I've got to go right 2 and down 3. My slope is negative 8. I'm going to fall 8 units and run both ways 1 to draw my V. Now, another transformation I missed was, since the absolute value of A is greater than 1, I have a vertical stretch. This thing is super steep. It has a factor of 8. So there was a big vertical stretch going on. Domain left to right, negative infinity to positive infinity. The range, negative infinity all the way to negative 3. Alright, let's go ahead and do set builder 2 on these. All values of x such that x is an element of the real. For the range, all values of y such that y is less than or equal to negative 3. And again, if you need to hit the pause, go ahead. I'm just trying to get through in lunch, and I don't have much time. Thankfully, I'm on the last page. Identify the following aspects of h of x equals 3 times x plus 12 minus 4. Now, you're going to have to do your FAFO thing here again. Factor and find out. Doesn't stand for what you think it is. It's factor and find out. So I noticed that I could pull a 3 from both pieces on the interior. All right, what's that mean has happened? Okay, so since a is 3 and 3 is greater than 1, there is a vertical stretch with a factor of 3. Now, if I focus on x plus 4, this tells me not right 4, left 4 units. Now, look at the negative 4 at the end. That's down 4 units. The coordinates of the vertex, we change the sign on the stuff inside, negative 4. We keep the sign on the stuff outside, positive 4. Or still negative 4. The slope of the V, that's your slope out front. That's the A value. So your slope is 3. And that is my initial slope. For a V, it's consistent. It's always slope. But I'm going to teach like initial slope for the next lesson, and the lesson after that, and the lesson after that. Anywho, there's your notes for that day.